Okay. So, zip it. Stop talking.
Shut up!
If I'm not being clear. Okay. We have a whole other lesson to get through in the next 37 minutes. Got it? Okay, now this lesson was planned for a Wednesday, so this is totally possible, but I need you guys to try a little bit harder to stay with me. I know it's hard because we haven't been focused all class, all year, but you guys are going to be in it with me this time, right? Yeah, you are doing really good, but we're starting to get a little off. So here, is it on topic?
It was about last time.
Okay, it has to be very fast.
What if will there be two U's?
It'd be two different integrals, but it can't be two U's in the same
It'll be like
integrand.
How do we know that we need to use U substitution?
If you try something else and it doesn't work. There's no rule. It's not gonna. The problem's not gonna say use substitution to find this integral. It's gonna say find this integral.
That's the thing I've wasted out.
Easy. It's literally rocket science, Kate.
Is that a picture of your dog?
But you guys, I'm gonna tell you right now. Guys, listen. I'm gonna tell you right now that a lot of you guys, I'm seeing this a lot in your test corrections. When a couple of you have come in for homework help, you guys are making your life harder by not having your rules memorized. A lot harder, okay? So it's not, a lot of these problems are not as hard as you're making them because you do not have your stuff memorized yet, and I can't help you with that. You just got to take the time to do it, okay? Okay, slope fields. Now, when we first learned derivatives, we started by sketching derivative graphs, right? And then we would find exact derivative equations. Today we're going to sketch antiderivatives, okay? Now, here's why that's weird a little bit. Any given function has how many possible antiderivatives? Infinitely many, okay? So hold on, listen to this, okay? Here's what a slope field is. A slope field is a method of graphing every infinitely possible antiderivative on the same graph.
So is the whole graph just like colored in?
Well, yes and no, kinda. Yeah, but we'll get there. Yes, Jacob.
Wouldn't that only be possible if there were like a circle or like something that had?
No, it's possible for any function. Okay? So, that's what we're going to go through today. We're going to start learning about slope fields. So let's try a couple. So you guys remember the dot game you probably played in Sunday school, right? That's what we're going to start doing a little bit.
I love that game so much.
I know, I'm awesome at that game.
Have you ever played triangle dots?
No. You guys drawing your dots?
No.
Like we're in a hurry, peeps, right?
No, I had to witness her A3 class. That was brutal.
You think it's brutal for you? I can't. I'm recording. But if you think it's brutal for you, then.
I forgot you were recording.
Oh, you were there the day that
Yeah.
it said that thing to me about the ACT.
Yeah.
Have you ever seen a teacher respond to a student like that?
Nah.
Okay. You guys, I'm sorry for interrupting your conversations, but we gotta move on. That's like a Demi Lovato type of a sorry, though. Okay? Okay, so what we're gonna do is we're gonna make a field of slopes. What does that mean, Miss Summers, you ask? Well, I'll explain, okay? I have some derivative function here, okay? And it has an infinite number of possible, wait, it's not what I want to do. Has an infinite number of possible antiderivative equations, right? I also haven't learned, well I have, but I haven't taught you guys yet, how to antiderive things in two variables that were implicitly derived. That's what we're doing on Tuesday, so bring your algebra pants, okay? But I can make a couple guesses about this, okay? I don't know for sure if the antiderivative of this equation goes through this coordinate at 2, 2. I don't if it does. But if it does, I do know what its slope would be there.
Yeah, it's just what is on the derivative.
Okay, so what would it be? -1. Because it would be -2/2, right? I don't know for sure that my antiderivative goes through 2. But if it does, I know it would have a slope of -1 because -2/2. Does that make sense? And I can eyeball and estimate what a slope of -1 looks like. Okay? Now, I don't know for sure if my graph goes through the coordinate here at 1, 2, right? I don't know for sure my antiderivative goes through that point, but if it does, what would its slope be there?
-1/2.
So that's going to be something that's still negative, but not quite as steep as that one, right? Now, I don't know for sure if my graph goes through the point at 0, 2. But if it does, I know what its slope would be there.
0.
0?
Yeah, right? Because 0 is on the top.
Yeah, he's right. 0. I just wanted to make sure. Okay.
Right.
Finish the slope field. If the slope is undefined, then you do either leave it blank or do a vertical line. Okay? Finish the slope field on all the dots.
It makes a silly little design pattern. Oh my gosh, that's gonna be something crazy about.
It's like warp speed.
2, 1. -2 over
There's
1.
positives right on the left side. They're positive.
Something over 0. Just leave it blank if it's undefined, you said?
Blank or vertical.
Okay.
0 is 0, right? Right?
I'm not very good at drawing.
You said it like 4 times. Vertical or leave it blank. Vertical or leave it blank.
Something so cool, I can already feel it, man.
Hey,
Oh,
this is what I got. You get this one? Okay, we're gonna make another one.
Do that quick.
I'm very smart.
Have you? She should teach.
Thanks, bro.
Exactly. It makes like a circle. I know, but I said that was a little bit louder.
Okay, make this one quick.
wait, but there's no Y.
Oh man. Okay, make this next one, Mace. You guys, today are playing about dots and fractions and not the calculus.
So then do you
I
just do
am
the
not-
X?
I am not emotionally capable today of dealing with complaints about dots.
Calculus is
Especially when you guys have lined paper.
I have graph paper.
Yeah.
But I did it right over the whole thing. So that's a problem. But it's fine. Yeah, so do you just base it off of the X value? Yeah, you still just plug in X. If this is 2, 1.
Oh man, that life was great. So much of it.
This is 1.
You know, it is your fault.
So you have the derivative graph, right? And then the derivative
Hey, before we chat about these, I'm going to have you make one more all on your own.
So I continue the derivative right there. It's X. So at 1, you plug in.
How come nobody pointed out my error?
What? I noticed it, but I was.
Why didn't you say anything?
I don't know, because I thought you did it on purpose.
Negative ghostwriter.
That's embarrassing.
It doesn't exist, so you just.
I'm not one of those teachers that's not confident with my math. I want you to point my mistakes out.
No, I thought.
Because then I know you're listening and you understand. You should have. Okay, last one, make it all on your own. And then we'll talk about them.
My hands are gonna hurt so much after this.
Were you supposed to put dots on them? Well, there's no dots. We're supposed to do it wrong. Well, I just don't want to be wrong after erasing. I got it.
You guys are worse than my 2-year-old today.
Well, look at that. She's doing the dots for you, Grace.
And my 2-year-old peed in my freezer yesterday. So.
That's unfortunate. That is a bit unfortunate.
Did it freeze?
Yeah. Yeah, I had to take everything out. Some freezer drawer, and she loves to be naked. She's trying to decide what was for dinner. Naked. Standing on the freezer drawer open. She peed in my freezer. You think that's funny? That's not the first time she's done that. And I'm telling you guys that you're driving me more crazy today than my 2-year-old who peed in the freezer yesterday. Yeah. Okay? Here's a little insight on this summer's life. There you go.
I feel like the second one I'm doing, or the third one I'm doing wrong.
No, you guys are doing really good today. You're just a little whiny, but you guys are keeping us good. I felt like you understood that last lesson I did speed version. Brandon and Simmers had to put the hammer down on the conversations and stuff so we could get through it. Okay, you guys got this last slope field there? Try again on that last one.
What? Okay.
Oh, meaning I meant make it on your own. But we're gonna talk about these
It's
specific
like reverse circles. It's like 4 circles, but only a quarter of each. 4 half circles.
It's a half circle, but it's like a circle, but it's like a quarter of a school. It's like a school circle.
I'm right straight up. Yaga.
Yeah.
Yeah, this one was weird.
Okay.
Sleep at night.
I think I did it.
This is color.
Okay, let's talk about these.
Yeah, there we go.
Oh, there it is.
Okay, guys.
This actually makes complete sense.
Well, good. Now let's talk about what they represent. Quiet, please.
Circle.
Guys. Okay. First of all, I want to talk about what Jack brought up a little bit ago. Okay? He said, well, if you did it, wouldn't it just all be filled in, right? Technically, I gave you an accuracy of a slope field of 1, okay? Because I had a dot every 1. But if I wanted a more accurate slope field, couldn't I then go in and say, okay, now do a dot every 0.1? How many slope lines would that add in any given square? 100.
Oh yeah, 100.
Right? But technically that's a more accurate slope field, but is that a complete slope field? No. You're right. If I did a complete slope field, it would just be all filled in, a black square, right? Okay? So the accuracy of the slope field just depends on what I'm looking for. As long as I can see the basic shape of the antiderivative, that's all that matters. Now let's talk about this middle one first, okay? I know how to antiderive this, right? If I were to take the antiderivative of that, hold on, guys. Just stick with me, okay? X squared plus C, okay? So this is a concave up, because that's positive. Parabola, because that's a 2. Centered at the y-axis, because there's no x term. with a vertical shift. Is that fair? Now, I want you to think about my definition of slope fields. I said a slope field was a way to graph every infinitely possible antiderivative. So what I want you to imagine when you look at this is every infinitely possible concave up parabola centered at the y-axis with a vertical shift.
So they make parabola shapes.
You see them?
Yeah.
So that means that this here is not for the parabola here. This is maybe for a parabola with the y-intercept of like -20. Do you see it? Look at the slopes. I'm making concave up parabolas, infinitely many of them, centered at the y-axis. This is the sketch of the antiderivative of this function. Is that fair? So take a guess what family of function this antiderivative is.
Circle.
It is a circle. It's a circle. This is the graph of this. It's a circle centered at 0, 0 with a radius of c.
Okay.
Right? Because look. Right? Okay?
It's 4 circles.
Nope. It's a what?
Rational.
Yes, good job. It's y equals c over x. 1 over x, right? The graph of what happens when my c is negative?
It just flips them.
So notice this is the horizontal asymptote, vertical asymptote. These are the ones for when C is, right, positive. And then these are the ones for when C is negative. Do you see it?
Yeah.
I'm going to say the definition one more time. A slope field, because now you know how to make them, but I want you to understand what they represent. It's how we sketch antiderivatives. It's a way to graph an infinitely many possibilities of the antiderivatives on a single coordinate system. Does that make sense now that you've seen it?
Yeah.
Good. Okay, I have some AP problems I want to try on this, if I can find them. If I were a stack of calculus papers.
Are they any of these papers? Is it this? Hey, Summers, is it any of these papers up here?
Yes. Thank you.
Yeah. Thank you.
Okay, I'm not going to have you try all of these for time, and I want to be able to go through them. Okay, we already did some of them. This is just notes. 1, 2, 3, 4, 5. Okay, so I want you to try 2, but then this isn't on the instructions, but I want you to take a guess the family of function number 2 lies in also. So try 2, and then 5, 6, 7, and 8, and then we're going to talk about them with your neighbors. Huh? Is this supposed to be what? I mean, depends on what you've done. These are AP ones.
The only thing I think we can do is slow it down. If you go,
So try 2, and then 5 through the end. You guys have 5 minutes, and then we're going to start talking about them.
Jack, can you get my shot?
I feel like I'm like 4th grade.
Yeah, me too.
Oh, really?
You can keep this paper. It's not homework. These are just AP questions. For online people, but I will put a copy on Canvas as long as I don't forget to.
to do the 0.5s too?
Just do whatever dots are on there.
Oh, there's dots.
Exponential.
With the graph.
It's like this on the top is what it looks like. I think it's exponential. Because it's bottom, it looks
So
like
you're doing number 2 and then 5, 6, 7, 8. And then when you get number 2 down, I want you to take a guess what family of function the antiderivative would be in.
I'm just gonna write exponential. So that's like,
The power of x.
yeah. How do you write that? NX. Oh no, it'd be
Yeah, like a constant. And then what's the constant is?
and it's centered around the x-axis. Yeah. So it doesn't have any shifts like this, but it'd have like an nx plus c, I think. Because it can shift horizontally. But I don't know, something like that. And then 5. For each problem, find a different equation that could represent it. This one we decided was a circle. It was like x squared, or sorry, x over y. Yeah. Well, except it was negative. Yeah, so I think it'd be d. This one's exponential, or not exponential.
It's like it's like
It's like the opposite. 6.
the thing isn't the same as the first one.
I think it's D. No. I think it's
It'll be 1 over y because the y values keep decreasing even more.
well, no, because y values. If that was the case, then the top 2 units would be the same, and the bottom 2 would be different because y's are. Because the negatives on bottom. Does that make sense? Because if negatives, because if this is, all of this is positive, so it's all going to be the same, like here. It's all the same. It's all the same.
Yeah, because it's similar to 2, right? So it'd be like.
I think it's D, because if you look, they kind of actually get smaller. Or maybe.
Let's just plug in a number, right?
It is hyperspace, right?
1 Would it be like 1 over x?
I think it is D because if you're plugging in numbers for it.
Well, because if we look at this one where we had x and stuff, like dy dx is x and stuff, they're just starting out. Like they're starting out steep and getting less steep in the middle, but this one's like the opposite of that. Like the reciprocal of that. So that's why I'm thinking it's 1 over x.
Yeah. Plug in a variable. It's not always going to be 1/2 because.
Oh, okay. For this one too. Oh, that's yeah. D.
Then you do 7 and 8.
Yeah. Consider the different range you go. Yep, that one.
So you're saying I get 1, 2, 3, and 4 for no reason?
So sketch a slope field for this one. Okay, so you kind of just plug it in. Yeah, so then it's 1 squared, which is just 0.
It's gotta be negative. Did you guys get D for number 5? Yep. Alright, alright.
It's hard to like draw them. The things.
Yeah.
Done?
Nope.
No, sir. Wait, but it can only be, it can only be B or A or B. It's not negative. So then that means that it's opposite.
We don't do
Oh, you just gotta figure out. They're both B. They're both B. Yes, they are. Now 7. So it's on the wire.
I think did it look like a weird star thing?
On the right
Yeah, I
side.
think
Yeah, that's what it kind of looks like.
On the left
It's,
side.
it's usually like this.
It's just the equation.
It's like a like that. Yeah. Oh, this like kind of hurts my brain or head. Yeah. The portion of the slope field equation is given below. Sketch the solution curve points 0, 1. So here is this point 0, 1.
this is so cool.
That's interesting, isn't it?
Like what would it would
I know, me either when I said I like teaching.
Through that
It's
point?
interesting.
I'm trying to follow it and I'm not doing a very good job.
I'm just kind of guessing.
I don't know, because one is much, I don't know, did it look kind of like that?
It looks like, yeah.
Nice.
It's not perfect, but I was just kind of like, yeah, sure. That's what it is.
Okay, we're moving on. I don't feel like drawing that slope field. I'm gonna just take yours. I'm sure it's great.
We'll see.
Okay. Does anybody have any guesses about what family of function number 2 was?
Exponential.
Exponential is correct. It was exponential.
But is it a horizontal shift or is it
Y equals C e to the x is actually the graph of that one. Notice the C, if it's positive, it's up, horizontal asymptote, no vertical. That's how I knew exponential. If C is negative, it flips upside down. What I'm interested about too is that none of you guys have commented that I've given you multiple examples today of C's that are not just plus C at the end, that are multiplied by our function.
Yeah.
We have no idea how to deal with that, but that's why you're going to put your algebra pants on. And Tuesday, that's when we're talking, when do we multiply by that integration constant versus adding it? It's a different situation, okay? Anyway, I agree. Number 2 is exponential. This is actually the correct antiderivative of that. Does that make sense?
Yes.
Okay. Annika's group got that both 5 and 6 are D. Does anyone agree?
Yeah.
So do I. Very good. Okay. You guys know that antiderivative rule. What's that antiderivative?
ln.
ln of x. Look.
But absolute value.
So that's why it's y equals ln absolute value of x. So remember, negatives aren't allowed in logs, right? But if I have an absolute value there, then if x is -1, I just make it positive for the y output, but the x was still a negative. That's what's happening here. That's why I have a reflection graph over here. Does that make sense?
Yeah.
Okay.
This is a good worksheet.
Oh, thanks. Okay, let's look at this. It's close, but I see at least one point that's not right.
Oh, it's 0, 1. I did 1, 0.
Wait. Isn't it the left? Yeah. Because
So negative squared or positive,
Oh.
and the y's are the same, so this side should have just been exactly the same. Does that make sense?
Yeah.
You guys, listen please. Listen please.
I didn't pay
Stop
attention
talking,
to that.
please. Okay, this one, number 7, I pulled from an actual AP test. This was a 2-pointer the year it was given. 1 point was for having all the right ones horizontal, and 1 point was for having the rest of them. So you would have gotten 1 out of 2 on that one. Does that make sense? Okay. Now, if you have a hard time keeping track, some people like to make table values, like tables of values, to help them plot these. That's not a bad idea. Any questions? Now, on this next one, 8 was, what, Ethan?
Well, I was just saying because it's squared, that means that the x is always positive, that means the function's always positive.
You got it, yep. Good. Okay, so now, let's look at 8. 8 was also pulled from an AP test. It was also a 2-pointer. 1 point was for getting the shape of the graph right. Do you guys see how these ones I can see the slope where they start to go horizontal, but on these ones I don't? That tells me that this one should be a little steeper than this side is. Okay? The other issue, that 1 point was for the shape. The other point was for the right y-intercept. A lot of people on this one automatically put the 0, 1 here, but you gotta watch your labels. Where Allie put it is right, because look, there's a line here that says 3, and then a line, and then a line. So this is 0, 1. Here, where the labels are at. Does that make sense? So notice, guys, couple connections I wanna make. Listen, please. Couple connections I wanna make. Notice that we have, depending on what our C value is, we have different possibilities, right? I can't figure out which is the particular solution wanted unless I'm given more information. I need at least 1 point on the graph so I can solve for the C value. Does that idea make sense? Mm-hmm. So on this one, I just graphed the C value given. Next class is when we're going to learn how to integrate implicit differentiation, ones in terms of x and y, and use this given point to solve for the C value.
Is that cosine for number 8?
I have no idea, but did you listen to anything I just said? Okay. Because it doesn't give me an equation, so I have no idea. No, because cosine doesn't get more horizontal as it goes up, so I don't know what it is. And cosine is symmetrical, and we said this side should be less steep than this one. Okay, are we good? Mm-hmm. I'm not trying to scare you. I'm just saying, do your algebra lunges. It's a big day on Tuesday, okay? Then Thursday's lesson is a little easier, and then get this. Then we are done learning concepts for calculus, and we start reviewing. Okay?
That's crazy.
All right. I don't want to hear it. I don't want to hear the complaining about my next comment. First of all, I'll do the good news first. We have like 4 minutes to spare on a 2-lesson day. Good job. Okay. I don't want to hear the complaining. Hold on, I'm going to be sassy, so I'm going to turn the video camera off.